Imagine you're looking at that stack and you see a big plume of smoke. Is that normal? Is it just part of the process? Or is it a sign that something's gone wrong? Answering that one simple question tells you pretty much everything you need to know about the health of the entire system.
And the answer is absolutely not. It is not supposed to smoke. Think of smoke as a big, flashing warning light. It's shouting that a really fundamental chemical process deep inside that incinerator is failing. It's a clear signal that something needs attention, and fast.
Okay, so to really get why smoke is such a bad thing, we have to first understand what the incinerator's job is in the first place. Its mission isn't just to burn random stuff. It's performing a very specific, very important chemical reaction that's all about protecting the air we breathe.
Here's the core of it. The incinerator's whole purpose is to take a nasty mix of sulfur compounds, especially hydrogen sulfide, that's the toxic gas that has that horrible rotten egg smell, and to oxidize them. It's a chemical transformation, turning these harmful gases into something much less harmful, sulfur dioxide, or SO2, before they're ever released into the atmosphere.
So the bottom line is this. When everything is running perfectly, when that chemical conversion is happening just right, you shouldn't see a thing. A clean stack means a clean, efficient operation. The second you see smoke, you know the mission has failed.
So how do we make sure that mission succeeds? Well, it might sound complicated, but it really just boils down to mastering two super simple fundamental rules of combustion.
And here they are. This is the mantra. Get it hot, give it air. Seriously, this little phrase is the key to the whole thing. So let's break it down, starting with that first part.
First up is heat. Obviously, right? It's an incinerator. But it's not just about being hot. It's about being in a very specific temperature window for that chemistry to work its magic.
We're talking about a target range of 650 to 850 degrees Celsius. In fact, a lot of operators are trying to dial it in right around 750 degrees. And this isn't just a suggestion. Hitting this temperature is absolutely essential for the oxidation reaction to happen correctly.
And you can see right here what happens when you miss that target. If you let the temperature drop below 650, the reaction just doesn't complete. That's when you get smoke, and even worse, you get that nasty hydrogen sulfide slipping right through the system. But if you stay in that sweet spot, you get an efficient, clean conversion. That's rule one.
Okay, we've got the heat handled. Time for the second half of our mantra. Give it air. And just like with the temperature, it's not about just any amount of air. The quantity is everything.
See, the whole system is designed to run with excess air. It's kind of like an insurance policy. To make absolutely, positively sure that every single one of those nasty sulfur molecules finds an oxygen molecule to react with, you have to flood the chamber with way more air than you technically need for the reaction.
How much more are we talking about? Well, the target is typically between 20 and 50% excess air. So, to put that another way, you're pumping in 120 to 150% of the exact scientifically calculated amount of air needed for a perfect reaction. This chart makes it really clear. That first bar, the stoichiometric amount, that's the bare minimum you'd need in a perfect lab setting. But in the real world, you aim for that second bar, that much higher operating range, to guarantee you get the job done right, every time. So how do operators know for sure they've got enough excess air? They're not just guessing. They have a live, direct measurement they can watch. The percentage of oxygen that's left over in the gas coming out of the stack. And that target is usually right between 2 and 4% oxygen. If an operator sees that number on their screen, they know they have plenty of extra oxygen in the system. It's the final confirmation that they're following rule number 2 perfectly. So, now we know the 2 rules for a clean stack. Get it hot, give it air. But what happens when things go wrong? Well, when an operator sees smoke, they don't panic. They have a game plan. Let's walk through it. But before we even look at the checklist, you have to know this one crucial fact. The vast majority of the time, the problem is a violation of rule number 2. The number 1 reason for smoke is almost always not enough air. So the troubleshooting plan starts right there. Step 1, every single time, is check the air supply. Is the blower on? Are the dampers open? Get the air right first. Only after they've confirmed the air supply is good do they move on to step 2, which is checking the temperature. Steps 3 and 4 are for looking into less common problems, but it all starts with the most likely culprit: air. All right, let's wrap this up with the key takeaways. First, smoke is never normal. It's a big red flag for incomplete combustion. Second,
The whole mission here is to turn harmful sulfur into less harmful SO2. And how do you do that? You master the two controls: temperature, between 650 and 850 C, and plenty of excess air. And finally, if you see smoke, what's the first thing you check? That's right, always check the air.
And that kind of brings us to a bigger idea. We've been deep inside one very specific piece of industrial gear. But these rules, they're universal. This delicate dance between heat, air, and fuel is happening all around us, all the time. So think about it. How does this same balance apply to the engine in your car or the furnace in your home? And what happens when that balance gets thrown off? It's something to think about. Thanks for watching.